Okay, I'm going to walk you guys through the ethanol fermentation setup and talk a little bit about the experiment. If you've learned about fermentation in other classes, you know that this is a process that's used by many species to metabolize sugars, and often it's done under anaerobic conditions, so in the absence of oxygen. Some species will carry this out even in the presence of oxygen, including the species of yeast that we're going to be using. And yeast will convert glucose into ethanol with a carbon dioxide byproduct. The highest concentration of ethanol that you can achieve from this process, though, is around 15%, because at those concentrations, the yeast will actually start to die out. So we will then take the ethanol in the following week and try to concentrate that using distillation. Now, if you take a look at the procedure, you're going to notice that we're not just feeding these yeast pure glucose, we're actually supplying the sugar in the form of sucrose or table sugar. And of course, sucrose is composed of 1 unit of glucose and 1 unit of fructose. So the very first thing that has to happen in terms of metabolism is for an enzymatic cleavage of the bond between the glucose and the fructose. This is carried out by the enzyme invertase, and this will free up 1 unit of glucose and 1 unit of fructose. The glucose will then enter glycolysis and be converted initially into 2 moles of pyruvate, and then finally will yield 2 moles of ethanol and 2 moles of CO2. Fructose can also be fermented, but we are not going to focus on that process in this lecture. Let's talk about how you are going to set this up. So in your 250 ml round bottom flask, you're going to add your sucrose, the yeast. Specifically, we're just using baker's yeast, which is Saccharomyces cerevisiae. When Pasteur did his work in the mid-1800s, learning about fermentation, he found that the yeast would thrive in this solution of mineral salts shown here. So they're called Pasteur salts. And you can read further about that if you would like to see what role they're actually playing in this process, but I will not go into those details here. But you can think of this as just being a nutrient medium for the yeast. And then finally, we are adding some DI water. Okay, so then you're going to take your 250 ml round bottom that contains the fermentation solution and sit that down into a 600 milliliter beaker. To keep the round bottom from rolling around, you want to make a little cushion of paper towels underneath it in the round bottom flask. So you're just going to crumple up some paper towels and shove them in there, basically. Then you want to fit the round bottom flask with your vacuum tube adapter and a stopper. You also want to make sure that you put ket clamps at the 2 joints there as shown. Here's what it looks like when it's all put together. Then you want to get a test tube and slide it down into an Erlenmeyer flask. And you want this test tube to be one of the larger test tubes. So if you don't have a larger test tube in your tote, you probably want to ask the TA for one. And you're going to fill that test tube about halfway to 2/3 full with lime water. And you can see here lime water is just a basic solution that contains calcium hydroxide. We'll talk a little bit about that in just a second. Then you're going to take a piece of tubing and connect the vacuum tube adapter to this test tube with lime water in it. And you do need to make sure that the tubing goes all the way down into the lime water. As the fermentation progresses, the ethanol will be forming over there in the round bottom flask. And the byproduct CO2 is going to be traveling through the tubing and down into the lime water. The reaction that's going to take place in the lime water will be the carbon dioxide reacting with the calcium hydroxide, and this will give an insoluble solid that you should see precipitating out over time. So one role of the lime water is just to be able to use it as a positive indicator that fermentation is actually taking place. But the other thing is that we don't really want oxygen to get into our fermentation as much as we can possibly help it. In the presence of oxygen, ethanol can actually be oxidized up to acetic acid, and we don't want it to be oxidized up that high. So we try to keep the system closed off as much as possible to the outside atmosphere. Once you have your fermentation set up, you need to make sure that you label it and give it to the TA. Most likely the TA will be collecting these on a cart, and we will be putting them in a nice resting place for a week. And then hopefully when you come back, you will have some ethanol in your flask.